Hello, everyone. Good morning, good afternoon, or good evening, depending on where in the world you call home. A few housekeeping items before we get started. All of our attendees are on mute, but we still like to keep our webinars as interactive as possible. If you have any questions throughout the webinar, please enter them in the questions section of the GoToWebinar panel, and we'll try and answer those as they come in. We'll also be closing the session with a live Q&A. So let's get started. Thanks so much for joining our webinar today, Managing IT at Scale. I'm Kyle Banaz, Director of Marketing at Netreo, and I'll be your host today. As mentioned, please send any and all questions, and I'll make sure we get them answered for you. I'm joined today by James Mancini, Netreo co-founder and principal solution architect. So today we'll be exploring the best ways to leverage distributed collection and monitoring to seamlessly manage your global IT operations, get better visibility into secure network segments and data centers, and lastly, improve your service levels all without adding additional labor burden. So with that, James, take it away.
Thanks, Kyle. So some of the common challenges that customers report when trying to scale up their management may be familiar to you. In any large environment, there's a legitimate need to gather data from different places around the network and even around the world, whether that be for monitoring application response or just keeping management traffic local. However, a common problem with this is running into limitations of the monitoring software itself. And this could be a problem with the performance at scale, or it might be a problem with the flexibility that the solution offers. But very often, it's a problem with the administration requirements for handling these complex environments. Ideally, you don't want the administrative load to scale up at the same rate as the environment. Another one of the most common complaints we hear is that the sheer volume of alerts that are constantly flooding out of the system overwhelm the command center or the engineers. So let's take a deeper look at these and see what the best tools are to address them. One of the biggest challenges, and one that drives many of the others, is the need for distributed data collection. In large environments, it's common to have multiple large data centers or to have remote compute resources that need to be monitored, whether those are hosted in remote corporate locations or in virtual private cloud data centers. One of the key reasons for this is the requirement to collect the performance metrics and latency locally so that the statistics are unaffected by network topology or load. For example, if I've got a data center serving APAC customers that's located in Seoul, it doesn't make much sense to measure round trip latency or application response from California, knowing that my international data lines are probably my lowest bandwidth and highest latency connections. The statistics are going to be much easier to interpret and compare if each application is measured from where the users are located. But we need to be able to do this without having to have multiple points of administration. Otherwise, the admin will scale up too, and that'll quickly become a problem. A key aspect of this is the ability to cache the data locally during a connectivity failure. So if I have remote locations serving local customers and my international link goes down or there's a routing disruption on my internet VPN, I don't want to have big blind spots and gaps on my data. So it's important that the local collector be able to continue monitoring and catch up when the link reconnects so I don't get gaps in my data. Being able to use distributed resources for collection is also an advantage when scaling. So if I can offload resource-intensive collectors like NetFlow or Syslog to a dedicated system without losing my single user interface into all of that information, that's going to be very valuable as I scale up my enterprise globally. Another factor is removing that intensive data collection traffic from my long distance WAN or VPN lines. So if all the servers in my sole data center are sending their log data to the local system, which is then just forwarding aggregated and report data as needed, I've taken a lot of that bandwidth load off my long lines and kept that traffic mostly local, and that's going to have a noticeable performance impact. Our approach to this uses what we call service engines, and these are remotely deployed virtual appliances that offload functions from our central Netreo platform. And the service engines can be deployed to perform several different tasks or can be specialized depending on the needs of the specific environment. I can deploy a service engine to offload collection of syslog or Windows event log data, for example, to keep that local to the servers, as we talked about. I can also deploy one, for example, to collect traffic or performance data to reduce congestion or just distribute the load. And I can also distribute performance telemetry and availability collection to a service engine. So if I've got an isolated DMZ segment, for example, I don't need to open up the firewall to collect that data. Or if I want to monitor a remote data center on the other side of the world, it doesn't make sense to backhaul all of that information. I want to keep it local. And that flexibility allows us to deploy the solution in several different ways, depending on the specific requirements of the customer or the environment. So let me just kind of go through a couple of simple examples. The most basic model is the traditional on-premise centralized model, where all of the performance data is collected directly by interrogating devices. And this is sort of the standard model that we're all familiar with. So all of the data gets collected from wherever they're located, but all of the storage and collection and user interface is centralized at that point. And the problem with this is that in a large environment, we're collecting data directly from remote systems or cloud-hosted devices, which might not be ideal from a security, configuration, or bandwidth perspective. So the service engines allow us to collect local data locally while using a remote collector to collect the data from those resources, which keeps the high bandwidth parts of that process local, and then pass that data back to the central monitoring system via an encrypted API. So all of the analysis, storage, alerting, and reporting can still be centralized. And this allows us to overcome some of the common bandwidth or security issues that you might deal with while still keeping all of the data and access to that data on premise. So this approach minimizes the bandwidth required, keeps traffic local as much as possible, but still allows me to keep all that data storage local. And we can use as many different service engines as we need to cover all of the different remote data centers or cloud hosting providers. Even so, all of the alerts, reports, and UI are then kept on premises. So with our system, if the connection to a remote poller is lost, the remote poller or service engine will cache that data to be able to send it to the primary system once the connection is restored, so we don't end up with those blind spots or gaps in the data processing. And all of the configuration and software updates can still be handled from that single central master console. Of course, we can also use the opposite model if that makes more sense in our environment. And this is kind of how SaaS hosted works, where there's a collector device or agent on premises, but the bulk of the data storage and the user interface is all handled in the cloud. So that allows us to also monitor cloud resources directly from the cloud. So there'll still be some data collection done directly there. And there could be multiple collector devices in different locations or different VPCs around the world. And this is common for web-centric organizations that are heavily cloud deployed. A lot of large enterprise customers don't have the majority of their resources in the cloud, and so they're not as comfortable with this model. But obviously, the cloud first approach is becoming a lot more popular nowadays, and people are getting more and more comfortable with the security and the topology implications of the cloud hosted model. Our approach allows you to kind of choose whichever architecture fits your environment. And if you've got regulatory requirements or requirements like that, it allows you to kind of tailor the solution to what meets those requirements best without adding additional administrative burden and complexity. So let's talk about that for just a second. So a lot of the issues that surround software scaling are based on the model that was used to develop a particular solution. Management software has traditionally fallen into one of two categories: easy to use software that's really slick and fast, but was probably never designed to scale, and then the big four legacy systems that are expensive, confusing, and difficult to customize. In the first category, these are often Windows-based systems that are designed for small environments. And these are very common at small and medium businesses, and they work great for that environment. But as organizations grow, they sometimes come along for the ride and don't quite meet the requirements anymore. They often use the approach of adding additional servers to scale, but usually run into issues with performance and administrative overhead. For example, Windows patching, licensing, antivirus, database licensing, maintenance requirements are all scaling up at the same rate we're adding systems and servers to collect that data. And the performance often suffers, which limits the maximum scale you can really manage with that kind of solution. And sometimes they also fall victim to their target audience. The same UI that works great for managing 100 servers suddenly becomes a huge pain when we're trying to manage 1,000 or tens of thousands of devices. Any software solution, for example, that requires you to implement changes individually on devices, that requires multiple different points of administration, doesn't really have a chance of being able to handle a large global network. When you get to that scale, it becomes so labor intensive to manage those solutions because they just weren't designed with the kind of workflows that you need for really large environments in mind. A lot of these solutions also offer unlimited licenses, which sounds really appealing as it should allow you to add as many devices as you need. But the catch, of course, is that it's usually only as many devices as one server can handle. And in a lot of cases, that's a lot fewer than you think. One very popular software solution that we tested started to have serious performance issues at only 1,500 devices on a single server. And that was without adding a lot of complex service or application checks or even running NetFlow. One company's design guide actually specifically says a maximum of 500 devices per server. And that really is not going to scale. If I've got 10,000 servers to monitor, that ends up being just way too many servers. The next category of management systems, the old school legacy big four solutions, what we call the dinosaurs, they're designed to handle really large environments, but they often have user interfaces that are charitably described as arcane and cumbersome. And even small changes or customizations to those systems can be really expensive and require specialized training or consultants. Now, it's important to understand that this is by design. Most of those companies make a lot more money from their service and consulting operations than they do from selling the software. So a lot of companies end up with these big platforms and they never get fully implemented before it has to be upgraded or changes have to be made. We actually had one customer that spent 3 years and over $2 million trying to implement one of these big four solutions. And they had to start over twice during that process because of software upgrades that came out that wiped out configurations or required changes. And then finally, after 3 years, they finally just decided to abandon it and change directions. And that's not even mentioning the ongoing licensing cost of some of those platforms or the maintenance dollars required. Scaling these systems often also means we're adding multiple different points of administration within the environment. So if I have to constantly add, a new user interface or a new admin interface to be able to configure a new feature, and it's not quite the same as the old one, it can really create a lot of training problems, it can create a lot of adoption problems, and it can really drag out the amount of administration that's required to keep that system working. Um, we also want to look at things like how difficult is it to do a software update on the system? Because if the system requires, multiple different layers of software updates, like operating system updates, antivirus updates, agent updates and patches, as well as software updates and patches or database patches, it can really start to pile on the administrative work that's required to manage these large systems. We've taken the approach of trying to make that software update painless. So for example, our software update is a single button, updates the main appliance, updates all of the service engines simultaneously. And for most of the upgrades, especially the maintenance patches, it's designed to not even interrupt operations. So you can do it in the middle of the day and it doesn't take anybody down. The user interface, the monitoring, the alerting, the reporting all continues to run as normal. So that's an important factor to think about when you're looking at these systems really to scale up. Another big one is the ongoing maintenance spend. There's a lot of places where the initial software purchase is a lot of the price, and then there's a smaller annual maintenance that goes along with it. But as you scale those solutions up, sometimes that maintenance really scales up quickly, and it can become very expensive to maintain those systems. You also have to factor in the costs of ongoing licensing for things like databases that are required to run it, operating systems that are required to run it, all the additional hardware, and that really leads to a lot of hidden platform costs. So sometimes the software is the least expensive piece of the deployment. Our approach by using an appliance-based system is that the database, the operating system, the software are all pre-integrated, so there's none of those hidden costs, and it's literally just the footprint of deploying however many collectors and systems that you need to be able to manage your entire environment. So all the costs are very straightforward and upfront. Now, our approach to solving these challenges is to really try to keep the administration, reporting, and configuration all centralized to make the scaling simpler. And by making sure there's a single user interface for all of these tasks, and one that's designed to scale with scalable workflows, we removed the requirement to create custom web pages, access multiple user interfaces, or even learn scripting languages to manage and maintain the platform. And this allows you to scale faster by deploying service engines as needed with just a few clicks, but everything is still managed and accessed from the same centralized web interface that you're used to. Our software update process, as I mentioned, is designed so you can either fully automate it or with one click, it downloads and installs the latest version without disrupting service and then pushes them out to all of the different service and remote collection engines to make that process completely painless. We take a distributed approach to the load problem as well, making sure that those remote service engines are distributing processing work so that you can still get all of your data from the single central console, but the heavy lifting is spread around, again, helping to scale to the largest network environments in the world. And our appliance-based approach means that by being fully integrated with no external databases to administer or provision, no operating system or antivirus requirements to keep up with, and no agents for most data collection, that's one less thing to administer, distribute, patch, or update. And our automation functions are designed to make provisioning and onboarding simple, even without manual intervention, even in highly dynamic environments. So the solution can be deployed in days instead of months or years and stays in sync even in DevOps-paced environments. So one of the keys to success in those environments and really being able to scale up efficiently is automation. And automating the monitoring lets you make sure that your monitoring system stays up to date, even when you're deploying resources dynamically across thousands of locations and multiple clouds. So we do this with a few different ways of automating the process. And one of those is providing a series of APIs to allow you to integrate into process automation or CMDB directly into the monitoring configuration, or to leverage auto discovery and find resources, even if they're cloud-based or SD-WAN devices, simply by leveraging all of the different possible APIs that we can learn devices from. So as new systems are provisioned in your environment, they can either be pushed into monitoring or monitoring can detect them and automatically start onboarding them. Because what we do is we drive the configuration of those using a rule-based system that allows you to define and identify things like device types, categories, applications, even templates that control every aspect of the configuration and do it all automatically. So we call this process auto configuration, and it comes with a set of rules to get started, which you can easily customize or create new ones to fit the environment. And we'll often go through with the customers as part of the deployment process and help them develop out this rule set. Because what this really allows us to do is to set device attributes like category, site, and business workflows based on any device criteria, like what processes are running, what ports it's listing on, what the device is named, or even where it's located. So there's no manual provisioning step to make sure they end up in the right reports or on the right dashboards, and they always get the right settings and alerts applied to them. So those can be automatically applied to devices as they're discovered, regardless of what method is used to add them in or what platform they're running on. And they can be reapplied as desired. So if you want to make sure everything stays locked to your configuration, you can enforce that. Then using those criteria that we set with the auto config engine, we can dynamically apply all of the relevant settings via a cascading template system. So this ensures that all of the different settings we need are applied to that device without manual intervention. So for example, a new SQL server coming online would not only get the basic Windows server settings, but then could get additional templates applied to apply SQL specific application checks and settings, or even override settings that are coming from the higher level templates. So it's a truly cascading system, and the settings can come from many different layers, making sure that we get all of the nooks and crannies covered. Make sure the SQL team gets alerted when there's a problem with the database. We can even do things like look for database server is named production. It can add extra checks for that. It could add it to different reports or put it on different dashboards. You can also use those templates to define authentication, escalation, and even event-driven automation. So it's designed to be flexible enough that a large global enterprise customer can use this to fully automate their process of managing systems and responding to incidents automatically, but still be simple enough that a small IT department can use it without a lot of training or dedicated personnel. So these are all things that you can customize, not things you have to hire consultants to handle or script for you. One of the other things that we hear a lot is that alert overload is something that almost everybody has to dealt with at one time or another, and it becomes more and more of an issue as the environment scales up. So some of the most common complaints that we hear are things like, inbox is exploding with notifications, sometimes hundreds or more a day. And at that rate, nobody can possibly hope to keep up with all of them, much less make progress on solving the underlying issues. But as a result of that, then the operators and engineers start ignoring or even filtering out the alerts. And that leaves you waiting for user complaints when a production application fails. Ignoring alerts like this is really asking for trouble, because somebody is inevitably going to ignore the wrong alert someday, and you're going to have a major outage on your hand that could easily have been prevented. When the users call the help desk because the last member of the database cluster failed, you're already deep in the weeds. And this can even be worse than not having monitoring in place, because management might feel secure that things are being watched closely when the reality is just the same as being blind. Now, this also can then mean that organizations, even with multiple advanced monitoring systems in place, get stuck in this firefighting reactive mode where they're just reacting to alarms as they occur. They're never really getting ahead of the problems. They're never preventing outages before they affect users. And in some cases, they're even missing real issues, things like critical alerts that are just lost in the avalanche of noise that's coming out of the system. So how do we keep everything well monitored without flooding the command center with alarms? So our approach to this is that, as a general rule, we recommend reserving actionable alerts for active items. So in other words, if you're not going to react to a notification as soon as it comes in, you shouldn't be getting an alert based on it. For example, if I'm getting alerts when the hard drivers reach 90% utilization, but I'm ignoring them because it's not urgent right then, two things are going to happen. First, sooner or later, you're going to get a server failure because you forgot to circle back on that alert. And second, you're conditioning yourself and your teams to ignore alerts. And I've already kind of talked about what happens when you do that. Instead, our approach is to use detailed reports. So for example, every morning I get a list of servers with the lowest drive space, and I know if I go deal with the top few entries on that list, I get to sleep through the night. I never have to act on a reactive alarm that's coming in the system. And that reduces the number of total alarms that I'm having to process as well. So in addition to getting more proactive, it's also solving that alert fatigue and alert overload problem. But a key point to make that work is to make sure all of those reports are automated and scheduled so nothing gets missed. We designed our platform so that almost anything you can view in the web interface, you can instantly turn into an automated report and send it out to any number of recipients daily, weekly, or monthly without any special training or SQL knowledge, without having to use an external reporting tool like Crystal Reports. That is, those generally just a kind of a pain. Another thing to consider when you're scaling up is how you're managing your notifications. So during a major outage, I need to be able to reliably communicate what's going on to all of the different teams and stakeholders. And my monitoring plan needs to address exactly how I'm going to get those notifications to people, factoring in the difficulties that are inherent in a mass outage. So, email and SMS are usually the foundation that most notifications are built on, but those may be highly impacted or unavailable during a crisis or just saturated with alerts and notifications. So we want to look at other alternatives. For example, if you're using our mobile application, you can use mobile application push, which takes a path entirely separate from email and can even be initiated from the cloud so that the state of the internal networks don't affect it. I also strongly recommend using API integrations with things like team communication platforms. So things like Slack or Spark or Teams, other platforms like that, because what they allow you to do is to communicate to multiple members of the team simultaneously. So everybody kind of stays on the same page and they know what's being done, when, and by whom. And after the fact, I've got a record or a log of everything that was sent and who sent it. So one of the advantages there is that if I'm using email for notifications, I can't verify that any particular person saw that notification or got that notification or what order they happened in without fishing through everybody's inboxes, and it's just a mess. So I can go through my logs for my system and see what was sent, but I don't know what was received. Whereas with the team communication platform, usually you've got a really good log and timestamps of all the messages that were sent out, and sometimes even who received them and who acknowledged those messages. And it just makes for a much nicer experience when I'm trying to go and do after the fact forensics or root cause analysis. It's also a good idea whenever possible to centralize those alerts and kind of roll them into a single dashboard, because duplicate alerts and conflicting status that come from multiple tools can cause confusion. You can have different engineers trying to work on the same problem, in parallel, unaware of each other, barking up different and sometimes both wrong trees, or can even lead them down the wrong paths and delay resolutions that way. A single point of alerting also provides a single point of acknowledgement and a single truth that everyone can work from. So we've got kind of a standardized pool of information that's shared among everyone. So you don't run into finger pointing problems where our team says the application is fine, but your tool says that the application is not fine, and whose tool is right, and what are they looking at, and are they even monitoring the same things? So it can also help to eliminate those kind of information silos. So teams that perform their own monitoring exclusively tend to cause problems. And the reason for that is that teams that do their own monitoring with no oversight tend to try to hide their dirty laundry and apply temporary fixes. And as a result, you end up with more outages, longer outage times, and a higher percentage of recurring outages. And if there's no oversight, often senior management is unaware of the number or scope of those outages. It is, however, fine and highly encouraged to give the teams their own customized view into what the command center sees so they can focus in on their area without feeling like they're starving for tools or for visibility. But you don't want them doing their only monitoring outside that master central console. We also want to make sure that we're leveraging all of the other types of operational systems that we might already be using. So things like notification managers can simplify on-call schedules, provide a way to distribute alerts that's not depending on your internal mail infrastructure. Many organizations are also using some kind of ticketing or ITSM system, almost always at large scale, and you're going to want to make sure that our monitoring plan includes how the tools are going to be used during a crisis and how they're going to be integrated with the monitoring alerting system. So for example, are you going to have your monitoring system automatically create trouble tickets, or do you need an operator to validate that it's a real problem before creating that trouble ticket and kicking off that workflow? You need to think about these things and kind of have a process outlined in advance of having real problems with it. You should also integrate your monitoring system with things like CMDB or inventory systems if you have them, because it can help to make sure that new systems get monitored quickly. And it also helps by making sure that things like decommission systems or configuration changes aren't triggering false alarms. Another great tip is to start using information radiators to share status information to improve communications during a crisis. And an information radiator is just a system designed to display important status information in a public area. So it could just be a monitor on the wall of a hallway that everybody has to walk through, or a piece of information that's I'm embedding on my internal intranet page that everybody logs into in the mornings. Teams can display things like application views or more technical views or very high level views, just depending on what the audience for those are. And this allows you to keep all of your teams in sync, not just for status data, but also for things like useful operational metrics, so response time or transaction velocity. And our platform builds a really easy way to create custom dashboards and summary data using a simple drag and drop interface for exactly this purpose. Using information radiators also allows you to actively demonstrate team values. And what we mean by that is that the team has nothing to hide, and that the team is also acknowledging and confronting problems in the real world. So it kind of, puts on display how good your monitoring is and how effective your processes are at managing those and keeping the alerts, dealt with and handled, so you don't end up with, what I like to call monitoring system measles, where you have so many red alarms on the screen, you can't even tell what's happening. Another way to reduce this alerting problem is to take advantage of built-in technologies like root cause detection. And so automated root cause detection is going to help by eliminating a lot of possible causes and drastically reducing the number of alerts that are generated especially during major incidents. And that's going to reduce distractions and avoid unneeded troubleshooting time. So what we want to do is we want to make sure that the tool itself knows about the topology, whether we configure that or whether the tool discovers it like ours does. It allows you to determine the reason, for example, that all the remote devices at a location suddenly went unreachable is because the router went down. So instead of sending out notifications for every switch, every server, every wireless access point at that location, I can actually send out a single alert that points me to the WAN router. And I can use that incident management rules to handle special cases. So for example, one of our customers has a lot of remote locations with low speed links, and when they ran out of bandwidth, they'd order an upgrade, but it would often take a month or more. So they'd put in a rule that said whenever they see a bandwidth issue on a site that there's already an upgrade on order for, send an email to the branch manager to let them know that they're aware of the problem and that the new circuit's already on order and they don't have to call the help desk. And they were able to reduce calls into the help desk for those issues by 80%. We also build in a lot of tools to help you tune alerts. So this helps you identify what I like to call noisy birds. And these are the few configured alerts that are responsible for a disproportionate amount of alarms, or those where an adjustment of the sensitivity alarm might be required. So I can use things like template baseline reports to see which alerts are being generated, which alerts are being generated by which templates, so I can make changes to those settings directly that will then automatically roll out to all of the devices where that template is applied. Again, it's an admin force multiplier. I can make one change that then affects tens of thousands or hundreds of thousands of devices, so I have maximum admin efficiency. It also allows you to do things like use our notification summary reports to see exactly what alarms are going out and how many alarms are going out from each device or from each type of application check or threshold alarm. Or if you don't want to manually do that, we also have a feature we call AAOps Autopilot. And this allows you to examine the configuration of all of the different system elements within the platform itself and looks for things that it can optimize. So things that are misconfigured or not integrated properly, or things that are configured in a way that's contrary to best practices. And then it can provide reports and recommendations, or even automatically apply those fixes to all of the various configurations within the platform without manual intervention. So I can, again, reduce the admin burden further It also reduces the training load, and it ensures that the tool stays optimally configured for your environment without a large time investment. And the machine learning models and recommendations and best practices are continually updated from the cloud to make sure that as other customers in your industry or with similar platforms find new and more efficient ways to do things, or the industry standards change, the platform continually stays up to date and continually self-tunes.
All right, awesome. Thank you, James. That was absolutely fantastic. Um, so I do want to remind everybody before we get into these last couple slides here, please remember to, or feel free to ask your questions using the questions box. We'll be opening up Q&A in just a moment. So I see that many of you today are not Netreo users. So for the uninitiated, Netreo was founded in 2000, and we've been in the business of full stack monitoring and AI ops for over 2 decades. So users of the Netreo platform come from all over the globe in just about every industry you can think of. And the Netreo platform plays extremely well in industries that are highly regulated, like finance, aerospace, and transportation, require high reliability and scalability, like healthcare and life sciences, and have real-time mission criticality, like emergency services. So backed by years of data and multiple patents, Netreo is recognized as a leader in IT management and monitoring. So we've been recognized as Network Computing's Monitoring Product of the Year for 4 straight years. We were recently named a high performer in G2 Crowd's enterprise monitoring, network monitoring, and IT alerting grid reports. So Netreo is also the highest rated vendor based on customer reviews in the most recent Gartner Peer Insights Voice of the Customer report. In addition to that, we were just named one of Inc. 5000's fastest growing companies for the 4th straight year. So we have a few minutes left here. So I'd like to open up the floor for some additional questions. And while we do so, I'd actually like to open up a poll as well. So in that poll, please let us know how we can help you further. Okay, so looking at these questions that we have here, so the first is, I'm interested if we may get a copy of this presentation. Yes, absolutely. So after the webinar concludes, in about 2 hours, you will get an email. So feel free to respond to that email. That'll actually go directly to me, so kbanaz@netreo.com, and I'm happy to share this presentation with you in a PDF form. So another question we have here is, so this is related to the poll, I believe. It says, what is the Netreo swap out program? So Netreo is offering special pricing of the Netreo platform for the equivalent functionality of your existing monitoring platform, but we're actually offering that at 25% off of your current annual monitoring vendor subscription. So feel free to reach out to us about that. We'd love to talk to you about giving you better monitoring for a better price. So James, another question that I have here, and this is for you. So we talk about managing IT at scale. So how many devices can the Netreo platform monitor at one time?
So the system itself is actually designed, as I talked about, to have a distributed collection. So what we typically say is that in a regular IT environment, a single appliance is good up to about 20,000 devices under management, and beyond that, you'll want to scale out with those service engines. And then each of the service engines can handle between 5,000 and 10,000 additional devices, and you can have up to 1,000 service engines linked into a single Netreo platform. So beyond that, so that gets you into the 500,000 or so range. And then beyond that, you've also got the ability to cluster multiple Netreo appliances together using our overview platform, which is often used by MSPs to manage, multiple customer environments, but can also be used by large enterprises to scale up to, millions of devices under management. The overview platform is designed to link to up to 1,000 Netreo application masters. So that would get you up into the, 50 million range, which is far larger than any of our customers have actually requested at this point.
Awesome, thanks for answering that, James. So you also mentioned that the Netreo is a virtual appliance, and so there's no Microsoft OS or anything that you have to worry about. So compared to a tool like a SolarWinds, how does the uptime of Netreo compare?
So by being appliance-based, it's given us an opportunity to kind of very tightly control all of the different operating system and database functions within the tool. So a typical Netreo deployment is going to be 5 nines of uptime, which is well beyond what you can usually achieve in a Windows environment. Beyond that, you can also implement our high availability option, which creates a cluster of appliances that will automatically fail over in the event of any kind of hardware or other kinds of problems that might affect one of the systems. And so in those environments, you can get truly, 100% uptime for most environments. So it allows you to get what we would call utility grade uptime using the high availability platform.
Awesome, thanks, James. So I've got one more question here. So we talked about automated device onboarding and managing the devices at scale. So can you tell us about a customer where we've had near zero touch administration at a large scale?
Yeah, so one of our customers actually was kind of the first one to really achieve zero touch automation, and basically what they're doing is by using that kind of rule-based system to detect what's running on the system, where it's located, using their naming convention to determine kind of what applications it's a part of. They're able to drive the configuration for those devices so that all of the right service checks and alerts are configured, all of the right performance thresholds are added, and that they're automatically put into all of the right reports. So as we discover new devices, whether that's from scanning the network or from attaching to APIs like vCenter or AWS or SD-WAN providers like VeloCloud, for example, as new things are provisioned in that environment, they can automatically be brought on board into monitoring and then automatically configured so that they really never have to touch the platform. And we've been able to achieve that for several of our larger customers now as well.
Awesome, thank you, James. So just one more question here, and I knew this one was coming. So how do we receive the Amazon gift card? So as I mentioned after the first question, so all of our attendees today, you'll be receiving a link or an email with a link to the recording of this webinar. That'll come out in about 2 hours from now. And in that webinar, you will also be receiving a custom link to a Google form. In that form, you can share your preferred email address to receive the Amazon e-gift card, and then we'll get that sent out to you within a week or so. So I just want to double check, make sure that we don't have any additional questions here. So it does not look like we do. So James, any closing thoughts or remarks before we close out the day?
Not for me, no. Thanks everyone for your time and attention, and look forward to talking to you soon about your own individual environments.
Awesome. Thanks so much, James. And yeah, we look forward to speaking with you. Don't hesitate to reach out. You can see info@netreo.com there. We're happy to get any questions answered for you. And with that, thanks so much, everyone, for attending, and have a great day and a great weekend ahead.